Okay, hello everyone. So this is going to be a quick video introducing the Lab 2, which is due October 30th. And by the time you see the video, there'll be an option here that you can, or expandable window you can click on and get the instructions and submission details. But for now, basically what Lab 2 is going to do is to give you some hands-on practice to manipulate some of the code chunks that we looked at during the last video lecture. And again, it's trying to combine two really, you know, large bodies of information, working with US Census data and also working with spatial data and mapping, which are two topics that could be taught separately, but we're trying to combine them together as efficiently as possible. And essentially what we're going to do is rerunning some of the code with a focus this time on getting information from the census that allows us to calculate the house price to income ratio across the US counties over space and over time, okay? And in the lecture, I gave you the variable name for the median household income. Basically what the first part of the lab will do is you'll have to look up the variable for the median household price. And if you scroll down here, I give you an important hint or a note. When you search the database using the load variables command and looking back at the lecture notes how to do this, you'll want to type in the key term median value to find the actual name of the variable, okay? But what we're going to do is using the very similar code that we had from lecture in the last video, transforming the data. You're going to be creating a home price to income ratio, where, for instance, one variable is going to be home price, one variable is going to be the income, and you're going to use this code to create a new variable, house price to income ratio, and you'll be dividing house prices divided by the income. And this will give you the ratio essentially of how long it typically would take for the median income household to purchase a house. In other words, it's going to give you an affordability indicator across US counties over space and over time. So this lab is inspired by the City Lab report that came out last year. It was written by Richard Florida, which is one of the most famous urbanists. And he basically did some analysis where he used census data to get the median household income, and they also used Zillow data to get median household prices. So we're not going to be using Zillow data. We're going to be using the median household value within the census. But essentially, we're going to be doing the same thing that he did. We're going to be looking at the least affordable metros and the most affordable metros in our lab. And we'll be comparing his results. So for instance, his results, he finds Los Angeles is the least affordable metro. In our lab, we'll see slightly different results, but you'll have a chance to compare and contrast by going through the data. So again, the two main slides you need to look at, one, for step 2, transforming the data, you'll need to look at this slide. And for the step 1, getting the data, you'll want to be looking at this slide, getting employment figures. So again, instead of labor force unemployed, you'll be looking at household median value or the median price for house and the household median income. So you'll change this maybe to like values, or you can keep it the same actually, and just relabel these, change this for sure, change for this for sure, make it into different names that make sense. And essentially those are going to be the two main slides that you're going to be required to work with. Be careful to read the notes. Again, you'll need the census API key to even download the data. You don't need the API to access the metadata to search for the variable name for median household value. But again, then you want to explore the data. So we didn't look at this in the lecture, but essentially what you're going to get is for every U.S. county, after you transform the data, you're going to get the house price to income ratio for each U.S. county. And what you're going to want to do is you're going to want to get the most affordable counties, the 10 most affordable counties, the 10 least affordable counties using the order function. So if you have a data set called SendDF, which we created up here in step 1, you're going to order your variable name, in this case the household income to price ratio, and you can look at the first 10 columns using the head function to get you the 10 smallest values, which relate to the 10 most affordable metros. You can use reverse order to then order the data set in descending order from highest to lowest. And this will give you the 10 highest values, which corresponds to the 10 least affordable metros. So you can look, play with these commands. There's also, as a bonus, it's a more interactive approach. If you use the data table function, you need to download the DT library. But if you have your data name census DF and use data table, it'll create an interactive table that you can sort and order just by clicking it. So this would probably be the preferred approach if you can do it. And then you'll use the map the data, and this will be pretty much the same as the last slide here. So you can use the same kind of code here. So basically you'll just be manipulating the code you've already seen for the most part. You'll be changing the data set name, you'll be changing the variable name, but other than that, it should be pretty straightforward. So for after you go through the code through here, you'll be doing some exploration. So in step 3 above, that's here, you'll have the highest and lowest price to income ratio counties. You'll be asked to name what is the highest, which county has the highest house price income, that is, which county is the least affordable, and then just taking the mean of the house price variable to get what's the average time it would take for the median household to purchase their house. That's what taking the average value will tell us. And then a bunch of subsets related to that, do a comparison to what Richard Florida found using Zillow data. The second question relates to more of a temporal analysis. You'll basically repeat the first few steps here, steps 1 through 4. But in this case, instead of using the 2017 code, if you remember, we're using 2017. And again, we're using the 5-year estimate. So this time period, it refers to the estimates from 2013 to 2017. What I'm going to ask you to do is change this value to 2012. And that will give you the time period of 2008 to 2012, basically right in the aftermath of the financial crisis. And you'll basically repeat the same steps that you did for question 1, step 1 through 4. And you'll re-answer question 1. Okay, so what's the highest, lowest price to income ratio county? What's the average price to income ratio? And you'll be asked to compare and contrast the findings from question 1 with the 2017 and question 2, the 2012. Okay, 2008-2012 time period versus the 2013 to 2018 time period, 17 time period. Okay, so that's a temporal analysis. And then the third question is going to include more of a high resolution analysis. So instead of looking at the values in 2017 across all counties in the US, we want higher resolution. So we're going to change the county to tract. So instead of using the geography being county, you're going to set this to tract. And you're also going to add in, if you remember, we're going to subset the data that gets loaded into Arizona, and specifically the county, Maricopa County. So you would just take these 2 commands and you would add them, we put a comma and add them anywhere in this get ACS function for both the county and state calls. Then again, you'll repeat steps 2 through 4 that you carry out above, and you'll give some summary statistics within Maricopa County. What is the min, max, median, mean, and standard deviation for the house price to income ratio, specifically within Maricopa County? Compare and contrast the findings from above when you're looking in question when you're looking at the county level, and what is the average. So what is the average if you're just looking at the track level for Maricopa? Is it higher? Is it smaller? And what does it mean? Okay, so that's basically the introduction to the lab. Feel free to ask any questions if you get stuck. But again, basically there's going to be 3 main slides to work from. It's going to be this guy. It's going to be transforming the data, this guy, to create the ratio, and then also just getting the data will be a lot here. So these are going to be the 3 main code chunks that you'll be using to do the lab. Okay, so good luck, and let me know if you have any questions.